Ideas for Impact, a new podcast where innovation meets sustainability head on. Let's take a fresh look at how we do business. Changemakers are innovating solutions to some of the toughest challenges we face in our world. In the process, they are creating their own mark on industry. Our guests are rebels with a cause. They are tearing down barriers, redefining success, and leaving a mark on their industries. Our guests are the disruptors who refuse to settle for business as usual. Join us to unravel the lessons learned behind their failures and their triumphs and uncover the hidden opportunities for positive change. Co-hosted by me, Joanna Buczkowska-McCumber, and my friend, Deborah Host. Impact isn't the pitch, it's the byproduct. In this episode of our Water-Focused Ideas for Impact series, we dive into Marine Biologics, where science meets the sea to unlock powerful solutions. As part of the blue economy, this company is harnessing the untapped potential of our waters, not just to sustain life, but to transform it. We explore why embedding impact deep in the engine, not just the mission, could be the key to building real change. CEO Patrick Griffin and CSO Spencer Serin share how the world's most comprehensive macroalgae composition dataset paired with advanced prediction engines and green chemistry is driving innovation across food, beverage, and beyond. Let's get started. Hello, Patrick and Spencer. It's great to have you with us. So let's get started. Patrick, your story of building Marine Biologics is super interesting. Do you want to share with our audience, just to give everybody an idea of like how this all started and your big why behind building this company? What is the story?
Yeah, so Marine Biologics is actually the third company that I've been involved with in the starting and launch of a business from the ground floor. I admittedly come from a totally different sector. I'm a software and internet guy. So the world of biomanufacturing, sustainable materials, blue economy is a new space for me. I got interested in this category largely through some personal investments and explorations into novel materials and climate technologies. I developed a thesis around just, the transition story today largely is focused on renewable energy and a lot of direct air capture technologies. And a part of the equation that I felt like has been really left out is the transition from a fossil fuel-based physical economy, material economy, to one that is maybe built off of more sustainable inputs. So really, you think about this transition that we're investing in and is underway, without considering novel feedstocks that are the building blocks of all the materials around us that really get us away from fossil fuels, the story kind of is incomplete. You can look today at the chemicals industry, which is, anywhere from the top 3 or 2 industrial emitter of greenhouse gases globally to really start to get a feel for the picture. And so, the alternative feedstocks that are out there today, apart from fossil fuels, it's biology, it's biomass. And when you take a look at the equation of the availability of biomass that we need to feed and fuel the planet, there's already some pretty tricky math there. And then if you add into the mix materials and chemistry, you start to get to some difficult calculus. So my thesis that I developed was really just the idea, if we really want to complete the transition to a more sustainable future, we're going to need a lot more biomass. And where is that going to come from? Well, ultimately, it's going to have to come from the oceans. And so very quickly, I landed on got very familiar with macroalgae. It's a really incredibly charismatic organism, one of the fastest growing crops on the planet, and one that I think can be a cornerstone to the next generation economy that I think will largely be built off of a lot more than just fossil fuel, but increasingly more and more built on top of biological and sustainable feedstocks. So that's kind of my entry into this. And then I launched in looking for, what's going on in the macroalgae space. How can this be a big part of the expansion of available biomass that's going to power our industrial base in the future? And then just went down a long journey of trying to understand how we're going to bring online a novel crop that's ocean-based and has all of the potential that seaweed has, given the starting place that we're at today in the macroalgae industry. So that's the beginning. And then from there, I've assembled a team of chemists, product developers, commercial experts, operations leaders, data scientists, and AI experts and computer scientists to help us answer some of these big questions around how do we bring on line this very powerful crop and build a compelling business that's going to really drive scale and growth.
Thanks, Patrick. And over to you, Spencer. I want to hear a little bit about your story and how you came to be at this company. I know you and I met through a completely different company, through the Ocean Startup Project, and would love to hear like your story and your why. And like, I know this is a big sort of story of like a merger between you two, and that's really exciting. So I'd love to hear like your story, Spencer.
Mine's a little less glamorous. I didn't maybe go in with a particular thesis in mind. I'm just a lowly chemist looking for a way in the world. And when I finished sort of my lab career in 2016, I moved to Western Canada, Vancouver Island, and I made cheese for a year and a half. I've always loved food. And the challenge with, I think, academic research is often you're in your own academic bubble. So I was really anxious to go out and kind of experience the big wide world and see where it took me. And I didn't really have a particular plan of what my career was going to be. I knew I wanted to work with chemicals. I didn't know which ones. And being from the West Coast, I've always been pretty enamored with the ocean and the things that come from it. And through my cheese career, my brief cheese career, I found myself through that company doing postdoctoral research, feeding cows seaweed to see if it reduced methane, like a very natural transition from cheese to cow burps. So for a couple of years, I was a cow burp researcher, and there was a lot of interest around using seaweed as a methane-reducing feed additive. And I was able to study that to some extent and explore it experimentally in my postdoctoral work. And at the same time, I started a position as a food safety consultant, just again, always kind of interested in the more applicable area of science that I was studying. Started a consulting firm based around, food chemistry, and a seaweed continued to be a thoroughfare in my consulting work, because so many of the questions people were asking were like, well, what are the chemicals of seaweed and why are they valuable? Like, why people were starting to grow a lot of seaweed on the West Coast. There was a lot of emerging companies that had challenges quantifying the components that were in their seaweed. They were trying to valorize it. So to do that, you need to identify its components and hopefully make an economic equation for, this seaweed is high in this, so therefore it is valuable for this. And I just found myself kind of naturally being pulled in that direction. We founded a company with my co-founder who I did my PhD in chemistry with, Fraser Pick. So two PhD chemists, like really good business people to build a business, like really nailed the business part of it. But it was a really great experience for us because we had the opportunity to work with a lot of kind of startups and solve problems using our unique chemistry lens. We kind of came at these problems in a different way. And that company was called Spoits Enterprises, which was founded in 2021. Through that, we were able to do some work globally. I did some work with seaweed in Barbados, the sargassum invasive seaweed that was down there. I went up to Alaska. They were doing kelp farming in Alaska, and did a contract with our company to do a technical report on certain opportunities related to kelp biomass and what it could be used for. And when I was up in Alaska, I had the opportunity to meet a member of Marine Biologics. And then, met Patrick, heard a bit about his story. I said, where do I sign? And, kind of the rest was history. And it was a really great opportunity for us because we were a team of two with not a lot of strong business experience in actually forming a company or doing the kind of impact that we thought that this space was prone for. I think we're pretty good at the chemistry part, but, we're still learning on how to, balance the books and stuff. So it's been great to meet Patrick and the Marine Biologics team, and really amazing group of people that have been assembled, and we're just happy to be a part of it. And that's how I met you, Joanna, because you were guiding us through our sort of through a Spoits journey when we were working with the Ocean Startup, and we've been able to convert that into this work with Marine Biologics, and it's been a really great stepping stone for us.
Yeah, and I think like it's such a testament, I think sometimes to think about like how when you merge or you come together with another group or another team, like complementing each other's skills and and motivations for creating impact. Like you can do so much more together, which I think is so inspiring. So thank you for both sharing your story. I think it's like there's so much there.
In terms of the ocean, what was one of the early discoveries that stopped you in your tracks?
Spencer, chief scientist, you want to jump on that one first?
Well, I didn't know what chemicals were, where I was going to go in the chemical industry. And I had always been interested in the idea of utilizing biology rather than sort of traditional chemicals manufacturing to like grow our unique chemicals. But the first kind of major experience with seaweed-based biomolecules having particular high value was in this cattle methane reduction story. And that was in 2014 that the papers came out. Then National Geographic wrote about it. And then the farmer that I was working with that owned the cheese place, he's like, I have some red seaweed I feed to my cows. Maybe it reduces their burps. And I was like, is this a thing? Like, is this science? Like, is this how it is working? Because I hadn't even thought of, seaweed beyond the stuff that I see on the beaches, like, the bull kelp that we would use like Indiana Jones. Like I had never thought about using it as potentially a resource that we can turn into a biomolecule, like into a biologically active chemical that can have a global impact. And then I'm hearing that people are creating multinational companies based around a specific seaweed to turn it into a ruminant feed additive, and the regulatory compliance around it and all of the research in the papers, and some of them getting published in, journals like Nature. And you're going like, wow, okay, so like that's just this story. What else can this one class of organism do? And that was like a little less glamorous as I learned more about it, because I don't think the science is as compelling as some of the stuff we're doing at Marine Biologics in the methane reduction space. But it was a surprising approach to what was, the production of methane being kind of a major greenhouse gas contributor and all of the science around that. So I know that was the start for me, maybe a little less neat, but then as I delved deeper and seeing what from a food space and plant health and broader animal health coming out of seaweed, it's pretty amazing that one organism can contribute to all of these like major industries effortlessly.
Yeah, I mean, that's kind of what brought me into, sort of piqued my interest when I looked at macroalgae and ocean. It's a little bit less scientific and more practical. I mean, here's a crop that contains a vast diversity of compounds that can find their way into a multitude of industries. And again, when we get back to this idea of, how can we find new Lego blocks to build our material world that move us away from, a huge dependency on fossil fuels? Well, we have to look for crops that really have it all. And macroalgae is one of these crops where we can grow it. It grows some species up to half a meter a day, and it requires no inputs, so no fertilizer, no pesticides, no irrigation, and sort of like this incredible super crop that we can invest in and develop as a cornerstone to the next economy ahead. That's really going to be a lot more bio-based and more extractive from a biology perspective, rather than sort of like oil and gas. So that was kind of it for me. I mean, I again, and getting back to, where are we going to source sustainable feedstocks? And, the terrestrial farming and crops are pretty tapped out. And ocean is this very exciting area. And, the idea of growing seaweed and expanding it checks all the boxes on sustainability. And, again, we talk about it sort of being this very charismatic crop. Where seaweed is growing, good things are happening in the water column, and even good things are happening, from an economic perspective and labor and jobs and employment. So, how the starting point for our business is how do we make this a thing? How do we make this a reality that is scaled up to the volumes of sort of the monocrop world of like corn and soy, and can put a dent in the overall oil and gas hold on our material economy?
It's so interesting. It's actually so fascinating. Seaweeds, obviously, it's having a moment in the startup space, right? We're seeing like startups cropping up trying to tackle everything from, seaweed as part of like beauty products to textile to like feedstock, yes, but also like building material. We're sort of seeing everything, food, etc. And so in that respect, like as you think about your own company and where you're heading, and especially as you think about like the regenerative economy and contributing to it, how do you want to define that for yourself at Marine Biologics? And how do you really see your, the company playing in this space to not only like contribute, but also what I'm also hearing is like you're trying to actually actively transform a system, right? And so how do you want to position yourself? Like how does that look like for you as you're also like at the same time building your startup and at the same time trying to like change a system?
I'll jump in and take the first shot at that. I mean, we view our company and we position ourselves in the world of biomanufacturing. Today, what that means is sort of the identification of biomolecules that have sort of target functional properties for some kind of formulated product, whether it's in the plastics industry or the cosmetics space or agriculture or food. Identifying molecules and compounds or systems of compounds that can deliver certain functional properties and then finding ways to cultivate them and harvest them is the sort of world of biomanufacturing. And today, the primary tools that we have in biomanufacturing have largely been developed around precision fermentation, where you seek out a molecule based on its structure and the resulting functionality that structure will provide, and then engineer a unicellular organism like a bacteria to produce or secrete that molecule, and then you harvest the molecule. So that's kind of the biomanufacturing today for the most part. As you can imagine, there's lots of costs associated with that. There's huge scale challenges. That has really, where that's been the most successful has largely been in like therapeutics and sort of pharmaceutical industries where, small amounts can go a long way and you can actually sort of justify and break even on your unit economic costs. But when you start to move downstream let's say called down market into larger volume industries or applications that maybe can't sustain such a high price point, that's where sort of the economics really are quite challenged. And what our company is really, what we're trying to do and what we're developing is the capabilities to go in and take a look at a crop and then understand the natural chemistry of that crop, which can have tens of thousands of different compounds, where those compounds can be mapped out structure function wise, and then we can devise the tools to isolate and get at the biomolecules that we want to incorporate into whatever applications our customers are building. So it's really kind of a new approach to biomanufacturing. Instead of engineering, going through the significant journey of R&D journey of engineering an organism to produce a biomolecule, we're saying, well, let's take advantage of crops that grow really quickly, are sustainable, have a vast inventory of compounds with an equally vast array of functional properties, and go in and understand those, map that all out, and then devise the techniques to extract those compounds economically. So that's our approach. And I think what we're starting with seaweed. We're doing that first with seaweed. We've developed now the world's arguably the largest database in the world around the chemical composition of macroalgae and what drives that composition. We're building out the first farm to formula data set on macroalgae compounds. And we are then developing the computational engines to identify and map out the structure function relationships of the compounds within. So it's kind of a little bit of a different approach to biomanufacturing. We think, it's not, either or, but we think that it's a new path for securing the biomolecules that we're going to need to power sort of the next generation of products.
Yeah. And I'll just add, especially with, for example, the precision fermentation, in a lot of cases, those industries, they're starting from scratch. Like maybe they have a target in mind and an approach that's been identified. Like seaweed is not new. You mentioned like a lot of emerging startup spaces in North America in seaweed, but it's 30 million tons annually harvested. The majority of which is cultivated, in 4 countries, and And there's a wealth of knowledge and historical knowledge there, but those products are not, currently aligned maybe with North American sensibilities. And so there's this emerging North American cultivated seaweed market, just because we have vast coastlines and kind of a hungry workforce for these types of products. But we're kind of standing on the shoulders of giants, but we're in the grips of this sort of data and tech revolution, which is where we position ourselves as sort of a unique approach that hasn't really been, I think, explored just because of the challenges around computation and structure function, identification. If you start digging into the reasons you say these functional molecules maybe provide health or cosmetic benefits, you're looking at interactions with like microbiota on the skin or in the stomach. And these are very difficult mechanisms to elucidate using traditional kind of computation. And now that we're able to kind of compute at larger data sets, we can actually answer some of these questions. And then you go into the tons of different seaweeds being grown in tons of different areas with tons of different chemicals. It gets complicated very, very quickly. And we're just trying to position ourselves to provide some answers to allow the industries that want to use these biomolecules an opportunity to access them. So it's a little bit of taking advantage of what's been known traditionally and the places that it's been applied. Like we've identified all those industries, the more emerging ones, like in the bioplastic space. I mean, there's still some of that is new, some of it's not so much, but how I think it's being measured and valorized is relatively unique. So I think that's a great advantage that we have, and we would be remiss not to recognize the hundreds of years of work in cultivating random species of seaweeds that has already been done before us. And now we just need to say, okay, yeah, we like that one. Like we want that one there. So it's pretty cool.
I think it's becoming more and more obvious, at least to me and hopefully to our listeners, what your differentiator is. As you look to scale, do you look to acquire, partner? Like how do you decide who you collaborate with, grow? How does that, or are you just sticking to your course and going to continue doing this?
Yeah, I mean, for the stage of our business and where we're at, I mean, right now it's just nose to the grindstone, and we're just working with the team and the assets that we have right now to get to the milestones we need to then grow. And so I think we have very concrete material objectives in 2025 around customer acquisition and iterations and actual fulfillment of novel biomolecules that are tied to our customer engagements. And we have to prove that we need to prove that we can do that over and over and over again before we start thinking about where the growth of our business is going to be and the ensuing capital that we're going to need to grow. So I think it's really just right now it's about execution. Yeah, I think we have got the core competencies in place, both from a leadership perspective and also from a domain perspective, to execute and get where we need to get with the capital that we have right now. And, I think that in the back half of this year, we'll be in a better position to have more structured conversations about where we want to deploy capital and how much we're going to need.
So obviously your business is highly technical. What are some of the challenges that maybe you're experiencing or maybe that you're predicting in your own path as you scale this highly technical impact business? Well, and how do you navigate that?
Yeah, I mean, one of the things that we found early on, and it was actually the seed of our outreach and engagement with the artist formerly known as Spoits, which is Spencer's former company. We were running into a reality of dealing with, I would say, a fickle feedstock, a fickle crop like seaweed. Seaweed has a huge array, a huge amount of volatility and variability in the chemical payloads that it produces. So you can have, we just recently completed a research program with the Alaska Fisheries Department where we participated in the analysis of over 100 different tissue samples taken from across the state of Alaska. Same species, farm sites, a few miles apart, harvested the same way, harvested the same windows, and we were seeing variability, massive variability in the payout and the payloads of carbohydrates, proteins, and minerals to the point where it becomes like really difficult to think about like how do you scale the production of compounds when your inputs are very inconsistent and unpredictable. And we really started looking around and understanding that that problem of inconsistency in the feedstock is really kind of what's driving everybody's costs in this space. So people that are developing today, there's some really exciting companies out there building amazing applications in the plastics area, in the cosmetic space, and biostimulants and agriculture, all using macroalgae. But the real driver of cost ultimately is a consequence of this inconsistency in the feedstocks that they're using to produce their products. So Team Spencer and Spoit, what they've been working on for the last few years is a capability to develop a chemical benchmark from the biomass that's very easy to create, but allows for a control that you can then tool all of your downstream processes against, so that you can basically introduce them, a consistent starting point, which then allows for more scaled out production. So we've developed, that's kind of the core of our business, is that we are developed technology to stabilize seaweed in a shelf stable form that looks a lot like oil. It's kind of like oil. We borrow heavily from oil and gas, and we take that and we then are able to create different combinations of seaweed to create basically chemical benchmarks that have the same payloads from a carbohydrate, protein, and mineral perspective. And then we are able to run the analyses to identify and invest on the computation of the structure and function in these crops, knowing that the variability is really solved for. So I think that that's been a key insight for us early on, the supply chain. There's a lot of businesses out there in the seaweed space where they're getting hung up is really around supply chain and sourcing and trying to scale these products with a feedstock, an inconsistent feedstock that is expensive to begin with and drives cost even more because of its variability. That was an early insight that we've solved through an acquisition, and that now, taking that off the table, that variability allows us to then develop these tools to map out structure and function and identify biomolecules that are going to solve customer problems.
Yeah, and in some of our early customer conversations, those are the things that are really attractive to them, like the confidence in a consistent input in their product development with well understood chemical compositions, and then also minimally processed. We're trying to kind of leave as much of the seaweed in the ingredient as possible, as long as we can ensure consistent activity. And I think that's something that's been done very historically, but now we can kind of prove it scientifically. So it's kind of like a old meets new type approach, which is why I'm quite fond of it.
So as you think about your business, and obviously in today's world, which has many, many challenges to it, you're building a company that is global in nature, from in various locations, from Canada to the US to Europe. How do you approach that, right? That there's challenges in that, and being able to do that and do that well. What is your strategy to building a global company that is also like focused on impact?
I think the first thing is that there is a reality of working with seaweed. I mean, it doesn't grow everywhere. But part of our approach is that we are able to stabilize a biomass and then turn it into something that is like you can innovate off of, you can design things from. And so to stabilize it, we have to be close to it physically. We need to be in Alaska, on the ground, in northern Europe, where we can get a handle on the biomass and actually, stabilize it. And so that's the first thing. And the second part of it is with the global team. It is definitely a pain in the ass building a new company where everybody's remote. It's the first time I've ever done that. I feel like it's kind of de jour now. This is kind of like how companies are getting built out. It requires a significant investment in, I think, a lot of the virtual workplace software, building and establishing a virtual presence, I think is key. But I think at the end of the day, the thing that really makes the difference is just ACE project management. And we've invested in operations and project management, where we have a very detailed playbook, detailed roadmaps that are tracked, logged. There's visibility and accountability. We have regular check-ins. So it's kind of the systems and processes that we build around our daily operation that allow for the coordination to happen. And I think, again, the air support of, great project management, I think makes the difference.
And I'll say from the global perspective, an advantage we have, we've got core operations in Canada, US, and in Europe. And so when we're meeting potential partners, customers, collaborators, we kind of have someone close to a lot of them. There's always like, oh, you're in the, I don't know, whatever, insert a place here. Anywhere in North America, we seem to have someone close. And then all through Europe, which gives us a lot of avenues for partnership and collaboration. And, since I've been with the company for 5 months, my Rolodex is out of control. Like I'm meeting people that I would never even think of connecting with. And all of them are really excited to contribute their knowledge and expertise to building off this idea because it seems to resonate. And that's been really validating for the approach. It doesn't mean it's not hard, working in screens, but I'm quite familiar with my head in a rectangle. So I guess this is just life now. But it's, to Patrick's point, we've got some really good operational kind of techniques in the background that have kept us all honest and delivering at a high level.
Yeah, I mean, the only other thing I would add is that, we also have segmented our business around, we have commercial and product together. We have production and manufacturing together, operations together, R&D together. And then we just make sure there's opportunities for FaceTime, there's a lot of cross collaboration. And, again, all of the project management software and tooling and oversight is a big part of that.
That's big. I mean, to just like also, I remember speaking, Spencer, when you and I first met, and you're like, I've got like these big ideas and this is the things I want to do. And, I think this came, on the table at the time, and it was like, okay, well, my opportunities were like this little bubble, and now the opportunities are like the world, right? Which I think is like, this is the testament to like, if we do things together, there's so much more you can do.
When we think about the blue economy at large and talking about just big picture right now, we've got into like some of the nitty gritty, the products and the work that's being done. Step outside of that for just a minute and think more legacy, lasting impact, ocean conservation, this world of technology integrated with conservation, integrated with good. What does all of this sort of mean to your day-to-day? Like, do you really feel the purpose with your business, or is it really isolated and segregated, and sometimes you just have to remind yourself that your work is impactful?
I think anybody who's come across a podcast or an interview or read an article, with an entrepreneur working at Seaweed will, I think there's a lot of investment or there's a lot of time given to talking about the charismatic nature of Seaweed, that it's good for the water column, it's good for everything around it. And all that is for sure, it's true. I think from a very practical perspective, I like to think, I talk about the experience that we all have going into like a grocery store and buying a product or looking at a shelf, and you see like, here's the mainstream products that are all like generally oftentimes very problematic from human health and environment perspective. And then you have like the bio-based products that are all, better for you and maybe even perform better in different ways, but they're always really expensive. And I think the bottom line is, if we can find a way to bring the cost down for the production of these biomolecules that go into those products and make it less difficult to source them, that's going to be felt in our day-to-day experience as consumers, just that the cost of better products is going to come down. So that's really at the end of the day that one of the biggest parts of what we're trying to accomplish here is, how do we build a new feedstock that's highly sustainable, that can be inserted into the base into our industrial base. So we are experiencing that every day. And so, that's probably the biggest, 50,000 foot view of like where we want to have impact. And then I think just like why Seaweed, and it's the externalities that come off of the expansion of the cultivated macroalgae industry are tremendous and can be done responsibly. we can take advantage and use, existing untapped resources, literal reshoring, creating jobs, cleaning up the water column. It's a very positive future when you think about, more cultivation of the oceans and the ocean space.
And I get excited about the economy part of it. I mean, if we can really create businesses, and this has always been the thing that has resonated in my career in this space, every time we're talking about growing a seaweed cultivation network, that means there are new ocean-based jobs in areas that are relatively remote, that are ideally profitable and provide real value to those communities. And that's really exciting to work towards that. So that's what I keep thinking about.
Patrick, Spencer, this has been really fun. We've loved learning about the nitty-gritty details of how everything works, all the way to, the big picture of the vision that you're building. And I think that's super exciting and can't wait to see what happens in the next couple of years for you. So thank you for joining us.
Thank you. Thank you, John. Thank you, Deborah.
Thank you.
As we wrap up today's episode, we hope you're leaving with insights that ignite a spark within you. At the core of every story we cover lies the undeniable truth. What truly drives impact is the relentless pursuit of change, paired with a deep commitment to the greater good. We're always reminded that making a mark on the world is not an easy task and isn't just about breaking through barriers. It's about thinking differently about what sustainability means in our ever-changing world and what is possible in creating it. Thank you so much for joining us on Ideas for Impact, where rebels with a cause redefine the meaning of what is possible. For more episodes that challenge the norm, follow us wherever you listen to podcasts. And of course, always dive deeper into our journey with us at ideasforimpactagency.com. Until next time, friends, keep pushing the boundaries of what is possible.